All right, you are finding the pattern that is going on. So what happened with -4, 12, -36, 108? What's happening? We are multiplying it by 3. -3. Yes, we are multiplying by -3. Good. How about -34, -26, -18, -10? We are adding 8. Beautiful. All right. 4, 16, 64, 256. We are multiplying by 4. And then 1/8, 1/4, 1/2, and 1. Times 2. Good, yeah. We're multiplying by 2. If you're ever not sure of what's going on, you can pick a term in the sequence and you can divide by what's in front of it. So like if you're like, I know I'm multiplying something, I just don't know what I'm multiplying by. Here, you could take 1/4, divide it by 1/8. What you would have to remember, keep, change, flip. Keep, change to multiplying, flip that over. You get 8/4, which equals 2. Okay, that's how you can test it. For it to be a pattern, it has to happen every time, right? So then you could do it again with somewhere else. Like let's do 1/2 divided by 1/4. Divided by 1/4. Keep, change to multiplying, flip this fraction. We get 4/2, which is also 2. So that's a way to test and see what you're multiplying by. Okay? And for it to be a pattern, it has to happen every single time. Okay, which one of these would be considered an arithmetic sequence?
2.
2, how come?
Because it's only when adding.
Because it's only when we're adding. We're adding the same thing every time. So over here in the blue marker on the board, just a reminder, recursive, we added a difference. Our explicits, we added the difference to our first term and we multiplied it by n-1. Okay? What are we starting today?
Geometric.
Geometric. Okay. So let's explore this a little bit more. 3, 6, 12, 24. We are multiplying by 2 here. Yes. This is an example of our new thing, the geometric sequence. Okay. This time in the sequence, each term is the product of the previous term and some real number r. We're going to use r for a common ratio now. So our d was a common difference. R is common ratio. So ratio is when we are multiplying. We're going to complete some tables like we did before to explore the different kinds of formulas. Arithmetic had recursive and explicit. Geometric will also. Let's see if they're closely related, if they're totally different. That's what we're about to explore and find out. So, first one. My term number, my sequence term, and my term values. So right now we're using that same sequence, 3, 6, 12, 24, 48, where we're doubling each time, multiplying by 2. Okay. Remember, we use n to represent a term that we don't know, a value that we don't know yet. Okay. N stands for anything. It's any term. So we use it to find anything. What would the function notation be if it was a formula to find the second term? F of 2, good. So what would it be if I was finding the fifth term? F of 5, beautiful. So that means F of 3 is a function notation to find which term? The third. F of 4, the fourth, beautiful. And what if it was just F of n?
Question mark.
The nth term, yeah. It means anything. That would be an equation that works for anything in the sequence. Not one particular piece, but the entire thing. All right, so now let's use this information. How can we find the 10th term of this sequence? What could I do? Yeah, keep on multiplying by 2. Continue the process. We could actually, which is technically using the recursive process, where we just keep using the previous term to find the next term. So we're just going to keep on multiplying by 2. So I already have what, the first 5, I think. So it wants us to keep it going to find the 10th. I see some pencils going, so I'm going to wait. I don't want to go too quick.
Question.
Yes, sir.
So say
Not there yet.
Oh, not here.
We are about to do that, but I
Oh,
haven't shown it
I
yet.
was gonna ask about
People are writing this down right now.
Oh, okay. My brain's going like 7
Yes,
places.
yes, you're a little ahead of me. Just
That's how I was that one day.
yes, it's okay. It happens.
I have an idea, but
Okay. So we're going to use our previous term to find the next term, and we're going to use the previous terms by multiplying them by 2 each time. So here I got it filled out for you for 1 through 8. It wants term 10, so let's just do it 2 more times. So for me to get term 9, I got to take, what's the previous term? 384, and do what to it? Multiply it 2. So what is going to be my 9th term? 768. Beautiful. All right, how do I get the 10th term? All right, and what does that give me? 1536. Good. So that's taking my previous term and multiplying it by 2 each time. So I took my function notation. I took this my ratio, which was 2, and like for the 4th term, I took 2 and multiplied it by A3, right? For the 7th term, I took my ratio, multiplied it by A6. So how could I use it to find any term? What are we going to do? Take my ratio and multiply it by what? Not the first term. The what? It is a different term. What is it though? For my 4th term, I used A3. For my 7th term, I used A6. For my 10th term, I used A9.
oh,
It's the n-1. We use our previous one, our previous term, and we're going to multiply it by the ratio. So for this particular sequence, they did the previous term times 2. Yes.
So
Yes, your idea.
when it works, say we were asked to find the 22nd term in this sequence right here on the board.
Okay.
It was the 2.
Yeah.
Theoretically, could you do 2 to the 22nd power, then multiply it by the first term, which is 3?
No. But almost. But no. Wait for it.
Just thinking.
But yes. Here, you're ahead of me. Hold on.
Oh.
Hold on. You're ahead of me.
Still ahead.
Okay. Next table. Here we go. So now we're going to look at the explicit process. So that was the recursive. Recurse, reverse, we used the previous term. Was that very similar to the recursive that we used for arithmetic? Arithmetic, we added our difference. Geometric, we're multiplying by a ratio. So similar in taste, right? With arithmetic, we add. With geometric, we multiply. Okay, so that's the only small difference here. So let's see if our explicit ones are also some closely related to each other. So, starting with my first term of 3, I multiply it by 2 to get 6. Okay, explicit means I get to use my very first term each time. So to get to the 5th term, I went from term 1 to term 5. That's what, 4 terms? So I multiplied 2 to my original value 4 different times to get there, right? Ratio, 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 ratio. If I multiply it to itself, that's 2 to the 4th power. Okay? So to get to my 9th term, which we already know is 768, I can take my first term and multiply it by my ratio how many times? 8 times. Good. To get from my first term to my 9th term, we multiply my ratio 8 different times to get there. So that's 2 to the power of 8 times my first term. So our 10th term, which we already know is 1536, was our first term times my ratio how many times? 9 times. Good. So an explicit term for this one, we did the first term every time, then we multiplied it by the ratio. What was the exponent to my ratio? To get to the 10th term, my exponent was 9. To get to the 5th term, my exponent was 4. N minus 1. Good. So for this particular table, we can say we can find any term by using our first value, which is 3, multiplying it by the ratio, which is 2, raised to the n minus 1 power. Again, we do n minus 1 because I already have my first term in here. All right. We good? Any questions for me right now? All right. I would get into a habit of putting your ratio in parentheses just because a lot of times we're going to have a negative number, okay? And that's going to help us with our calculators, putting it in parentheses. So it's a good habit to get into, is just putting our ratio into parentheses. We good? Ready to graph?
No.
Whoop whoop. Yes, you are. You'll be fine. Arithmetic, they made what kind of shape when you plotted those points or when they're given to you? It was what? An arrow. It was a complete straight line, right? All arithmetic is linear functions. Do you think geometrics are going to be lines? No, it's not a constant difference, it's a constant ratio. So what shape do we think it's going to make? Some kind of curve? Parabola? Something? In math, you say parabola. In language arts, you say parabola. Fun fact. Same word, different sayings, different meanings. I know. You're welcome. All right, so let's graph this. We have terms 1 through 6. They go 3, 6, 12. It's the same sequence, okay? They are doubling each time. I'm going to, well, go back. Every other block, I'm going to put 10. 20, skip a block, which means essentially every line is worth 5. But I write kind of big. I'm not going to have room to put that on there. There we go. And then below, I'm going to skip every other line and count by ones. Go up to term 6. So this is our term number, which is the n. Over here, this is the actual term itself. So this is a sub n. That's the whole value. I'll give you a second to set that up. All right, and now we're going to plot points to the best that we can. So 1 is 3, so it's going to be about down here. 2 is 6, so just over that first line. 3 is 12, so just over 10. 4 is 24, jumping up here. 5 is 48, so we're almost at the 50. And then 6 is 96. So we are up here. Yeah, so it's not making a straight line. It is definitely giving us that curve. What's the name of it? Do you remember what the name is for those curves? We called them J curves. Nope, a quadratic would be a whole U. What's just the half? Starts with an E. There you go. Good. So these create exponential graphs. Yep, these create exponential graphs. So there is no common slope. It's drastically getting bigger, or sometimes will drastically get smaller. Whatever this is representing, it's growing over time. Hopefully it's like a bank account, right? That'd be nice. It's probably not a bank account. All right, so we have a couple more. What, 3 more? Okay. Any questions for me up to this point before we start doing actual problems? Up until now, we've been kind of exploring and seeing the similarities between this and arithmetic. All right, let's do something. All right, consider the sequence. That should be -2. The negative's kind of off right there. -2, 4, -8, and 16. So let's write the recursive formula for the sequence. Well, a recursive formula, we just found out, is a n minus 1 multiplied by the r. Do I know what my ratio is? My ratio, good, is going to be -2. So I can say any term can be found by taking the previous term and multiplying it by -2. This is where parentheses matter. Right? Oh, that's funny. It goes A. Does yours go ABC? Oh, sorry. Good times. All right, write an explicit formula for the sequence. So we already figured this out. That means I can use my first term, multiply it by the ratio raised to the n minus 1 power. Okay, well, do I have my first term? I haven't identified it yet, but it is there. What is it? It is -2. Good. Our first guy is -2. Times my ratio, which is also -2, raised to the n minus 1 power. All right, it wants us to find the 12th term. It hasn't told us how, it just says to find it. So which one of those equations would you like to use? Recursive or explicit? I'll use explicit. Do you know the 11th term? No, you only know what, the first 4? I wouldn't want to keep going to 12. Okay, I'm going to use the explicit formula. So I'm going to use a sub 12 equals our first term, which is the -2, times our ratio, which is also -2, raised to the 12 minus 1 exponent. All right, what is 12 minus 1? 11. Notice the parentheses. What is -2 raised to the 11th power? 121. -2 to the 11th power? It should be an even number. $20.48. Did anybody else get $20.48? Negative $20.48? I believe it's negative. Right? Yeah, so we're going to get -2 times negative $20.48. And then multiply that by -2, and we're going to get a positive something. 40.96. Very good.
Wait, what does the R stand for?
R is common ratio. That's what we're multiplying by each time. That's how negative 2 became 4 became negative 8.
Oh, I'm sorry.
Nope, you're good. You're good. We good? Questions on what we just did for that sequence? Because you about to do it in the next one. All right, work with your table, people. Do the next one. You have 7, 14, 28, and 56. Write the recursive formula, then the explicit formula, and then find the 12th term of the sequence. All right, check your answers with mine, please. Your recursive formula should be a sub n equals a sub n minus 1 times 2. How did I get times 2? It's not a difference. Careful. Technically, it's a ratio. Yes, I knew what you meant, but words matter because arithmetic uses difference. Geometric is going to use ratio. So yes, we are multiplying by 2. Good. Our explicit formula. We have 7 times 2 to the n minus 1. Where did the 7 come from? It is my first term. Good. And then for my 12th term, we plugged it in 12 for my n's. So we have a sub 12 equals 7 times 2 raised to the 12 minus 1 power, which does simplify to 14,336. We good? Just stands for term, which is what we're finding. All right, one more, last one. An art gallery was showcasing a 6-inch long photo of a geometric landscape. The picture was, oh my gosh, I can't talk. The picture was enlarged 10 times each time by 125% of the previous picture. Enter formulas that will give the length of each enlarged print. Okay, so a sub 1, what is my first term going to be of this sequence? It started off 6 inches. Good. What is the other thing we're going to need to know? We're going to need to know the ratio, okay? So how is it changing? 125%. First time I've had to take my percent, though, and change it to a decimal. Good. Take your decimal, which is next to the 5, and move it back twice. So it becomes 1.25. When you're multiplying by a ratio like this that's bigger than 1, that shows growth. If I was multiplying by a ratio that was like 0.2, 0.8, that's less than 1, that would show that you're losing value and it's decaying over time. Okay, so this one is growing, which it does tell me it was enlarged. So my ratio is 1.25. Okay. Does it even give you the term on how many times this is happening? It happens 10 times. Yeah, so it happened a total of 10 times. That's all the information they gave us in the description, okay? Now, what do I need to use to write the recursive formula for this? I just need the ratio. So I'm going to say a sub n equals a sub n minus 1. Am I going to add the 6 or multiply the 6? Multiply. Good, because geometric is all about multiplying. Multiply it by 6. Good. What's up? Yep, hold up. Hold on. You right. It's not 6. Just kidding. Yep, 1.25. I did that on purpose. Exactly. All right, our explicit formula, what do I need? Now I need the 6, my first term. Am I going to add or multiply the ratio? Multiply the ratio. And what's the exponent going to be for this ratio? N minus 1. So yeah, it didn't actually ask me what it was going to be. It just asked for the formulas. But if I were to answer the question, if it did ask me, how large will it be in the end? After being enlarged 10 times, you could plug in the 10 and figure that out. Okay, let's do it. Why not? Let's do it. Our 10-inch picture, let's see how wide it is after being enlarged. So we are going to have a sub 10 times 6 equals 6 times 1.25 raised to the 10 minus 1. So 6 times 1.25 to the 9th power. What is 1.25 to the 9th power?
Big number.
A big number.
Or big fraction.
Oh. I'm sure you did it right. I'm saying 1.25. Use your calculator. Is it this one? Well, no, because we want to do the power of 9. 7.45? 7.45. All right, now let's multiply that by 6. Times 6. And you get 44.7. So after being enlarged 10 times, the picture is now 44.7 inches long.
That's a big picture.
It is. It's almost what? Almost 4 feet? Almost. Not quite, but almost there.
12,000.
Okay. Questions for me right now? Alrighty. You have a worksheet to work on. It follows your notes exactly. Okay? The front, see those tables? The first one you're filling in using recursive. The second one you're filling in using explicit, just like we did in our notes. Answer some questions about them. On the back, we got some vocab happening in number 2, seeing if you know what the recursive and what the explicit process uses. Number 2, you have a sequence. I want you to write the 2 formulas and find the 14th term. Number 4 has you remember an Algebra 1 fact to help you out. And then number 5 is a graph. Okay? My hint for your graph, every other line go by 20. Okay? So every line go by 10 or every other line go by 20s. If you do that, you'll fit all the points on the graph. Okay? So double what we did in our notes. All right, work on it. When you're done, come get it. You can check your answers. I'll put them on the board, and you can get a stamp. All right?